Okay, so hello everybody. Welcome to another chemistry lesson. This is Boost Knowledge. Last time we talked about the group 1 alkali metals, and today we are going to skip the alkali earth metals, the transmission metals, the boron group, carbon group, nitrogen group, and the hydrogen group to go to group 7, the halogens. So why have we skipped so many groups to the halogens? Because the halogens have all bonds with the alkali metals. And later I'll explain why. But I think last class we did explain that a alkali metal, by donating its outer electron to a halogen, will give halogen and the alkali metal a full shell, and thus one is positive, one is negative, and they can attract and form an ionic bond. This ionic bonding, as we will talk in another lesson, but I'll skim through it briefly, is only available if all atoms have a full shell and can attract each other. Okay, so let's get started. The halogens then. We have actually, strictly speaking, 6 elements in the halogen group. But the last 2, including the AT one, you can just, ignore them, and I'm just going to, cross them out. Wait a sec. Goodbye. You just ignore them. It's not really much use, and you don't learn them in GCSE chemistries either. Okay, back to the main topic. So this is fluorine. This is chlorine. This is bromine. And this is iodine. Yes, so these are all the 4 elements we are going to be covering today. And the halogens, a very useful thing to note is that they are dangerous and poisonous, but not so if combined with other elements to form compound. And this compound thing is actually the ionic bonds we talked before. Fluorine is a yellow gas, poisonous. Chlorine is green gas, poisonous. Bromine is brown liquid, poisonous. Iodine is a gray solid, also poisonous. Although iodine can be used as an antiseptic and saves millions of lives, it's still mostly poisonous. But as we've talked in the last video, sodium chloride, NaCl, actually forms table salt, which is edible. So let's dive into the second point. The first is the elements, and the second is compounds. Forming compounds with halogens. So how can you form compounds with halogens? So firstly, can be diatomic. I think you know what diatomic means. It's actually 2 atoms which are together, like 2 fluorines together, or 2 hydrogens together, 2 oxygens together, etc. So in this case, they can have F2, Cl2, etc. I'm sorry, but I have to make this 2 down, and I can't do it with a PDF. Good. Just don't make it a 2, okay? Why does this work? And why can't you just not take another element, like anatomy, for example, which is Sp, and make it 2? So why can't you do that? The thing is that atoms need to have a full shell, and I'm taking my pen out for this. So here you have one, let's say fluorine, for example, and I'm only drawing its outer shell and its electronic configuration, of course. We learned that last class, which was 2, 8, 8, 2, 10. and the 10 is for A levels. You don't need to remember that. The first one will have, I'll draw them in crosses, 7 electrons on the outer shell. If you say fluorine, because fluorine is 9, it'll have 7. The other fluorine, I'll draw them dots, also has 7. I'll draw that in circles. You can't draw those in PDFs. And then you see that because this is to this one, this is to this one, all of them have a full atomic shell. And this is not ionic bonding, this is compounds. And then they like attract each other, and that's that, which is, well, good. Now let's move on to our next page. It's just one page of PDF to another page. I'll send the document if you want them, and to your email address if you want. So this is fluorine again. Okay. The second compounds is that they can bond with hydrogen, I'll just say H, carbon, alkali metals. So let's give some examples. So, for example, HF, which is hydrogen fluoride, CCl4, carbon tetrachloride, and finally, as we all know, NaCl, which is sodium chloride, which is also table salt. The thing about these is that if you draw the electronic configurations out, they will all have 4 shells. Why not take out the periodic table, look at the atomic numbers, and draw them out for yourself? And you can link them in the comments if you want. I'm not drawing them on the lesson because there's time. So this is the second part, bonding. The third is about trends. Trends about the halogens, like what they have. So when we learned about alkali metals, the radioactivity, melting points, and the boiling points, I'm not going to note that down here, and the reactivity increases. Why do they increase? I think we talked about that in last class, because it's easier to lose electron if high proximity. If it has high proximity, like for example calcium, it will be very far away from the nucleus, and it will be easy to lose that electron, and then this will have a full shell, and it could interact with another element. So this is the alkali metals. But halogens are actually the complete opposite. The radioactivity, melting points, reactivity, they all decrease because it is harder to attract electron if high proximity. Why is that? So, as we talked about that, halogens must gain an electron to complete this full shell. But if it's a very big element such as iodine, it can't do that. Why? Because, well, that's easy. It has a very high, it's very far away from the nucleus, and the attractive force will be very weak. It may not get the electron. Sorry, there's a misspelling. I just saw that. If there's anything you want to ask me, please tell me, message me in the comments. So let's move on to the next page. Okay, this is the last thing, and it's the most important thing we talk about in halogens: replacement. Replacement. That's very important. Why? So let's go. For example, think of a reaction which involves chlorine, which involves bromine and potassium. So the equation is 2KBr is this thing, and the original equation is actually 2K plus 2Br equals 2KBr. It's not 2Br, sorry, it's Br2. Wait. I think that's the equation, yes. That's the equation. And this is the original equation. So we get 2KB2, KBr2, sorry. 2KBr, right? Why is it 2KBr? And this time we added chlorine. And it's Cl2 actually. And then what do we get? You might say, well, it's already an ionic compound, so it'll just remain the same, it will not change anything. But then you're wrong, because as we said before, chlorine has a way, way, way higher reactivity than bromine. So what would happen is the Cl2 will combine with the potassium, and it'll become 2KCl plus bromine, bromine 2, like 2 bromines, like that. And this is the reason, because if you take out if you take out any element, you can see that the reactivity from iodine is lower than bromine, lower than chlorine, lower than fluorine. So if there was a reaction that involved iodine and potassium, then a fluorine could easily throw away the iodine and be reacting with potassium, because, well, the reason there's no exact reason, and it's too complicated. But the thing that you want to know is that atoms want a higher reactivity and easier to bond with it. So they will choose maybe chlorine over fluorine over chlorine, etc. Well, that's all you need to know. And a simple method of remembering this is a lower atomic number is more powerful than high atomic numbers in the halogen group, opposite in group 1. So that's a very useful tip you can learn. Lower atomic numbers are more powerful. This is grammatic error. Lower atomic numbers are more powerful than higher atomic numbers in the halogen group, but that's opposite in the alkali metal group 1. Okay, so I hope you've learned a lot in this class. We'll send you the notes and this PDF if you want, and it's linked in the description. Please subscribe for more, and I will see you next time. Thank you and bye.